The great vertebrate transition onto land over 360 million years ago led to an immense radiation event, resulting in the huge diversity of terrestrial vertebrates we can see today. Despite millions of years of adaptation towards a terrestrial lifestyle, a small group of primordial mammals made the transition back into the water, needing to readjust to the aquatic world they left eons ago. Over the next 50 million years, the descendants of these early mammals triumphed, becoming the group we now call Cetacea. Comprised of around 89 extant species, Cetacea is an infraorder home to the whales and dolphins, as well as many other aquatic mammal species. This group is separated into two extant parvorders. The first is the Odontoceti, the toothed whales, which includes species such as the dolphin and the sperm whale. The second is the Mystaceti, the baleen whales, which include species such as the blue whale and the right whale. Collectively, these two groups are known as the Neocetes, describing all extant groups of Cetacea. Let's travel back 50 million years to the freshwater habitats of southern Asia in the early Eocene, where we meet the earliest ancestors of Cetacea. With a thin coat of fur and small hooves, Pakicetus was a small artiodactyl ungulate which bared little similarity to the modern whale. One of the earliest members of Cetacea, it was the ancestor of the now extinct parvorder Archaeoceti. What set the Pakicetidae apart from other related ungulates, such as the rheoelids, were orbits positioned high on top of a narrow skull, perfect for peering out from below the water. Furthermore, the ear structure of the Pakicetids represented an intermediary between terrestrial and aquatic mammals, possessing the external auditory manus of land-dwelling taxa, whilst the presence of an involucrum strengthens its relationship with modern cetaceans. Nevertheless, their long limbs and small feet suggest that these creatures were poor swimmers. Fossils have only been uncovered near river deposits, indicating that the transition into marine ecosystems was yet to come. Confounding evidence of Archaeocete radiation was unearthed through the discovery of the Ambulocetidae. In the genus Ambulocetus, limbs became more adapted towards paddling than substrate support, and feet became wider and flipper-like, improving propulsion, similar to the hydrofoils of modern whales. It was thought to swim akin to an otter, allowing it to prevail in the brackish waters it inhabited. Isotopic evidence has shown that Ambulocetus fed primarily on terrestrial organisms, evoking that this predator hunted and behaved much like modern crocodilians. Within 5 million years of the appearance of the Pakicetids, artiodactyls had finally made their transition into marine environments with the evolution of the Protocetidae. In Rhodocetus, the vertebrae of the sacrum were loosened, indicating an improved swimming capability. Yet, despite these adaptations towards a heavily marine lifestyle, the fossil of a pregnant Myocetus depicted the unborn fetus positioned headfirst towards the pelvis. This evokes that the Protocetidae must have given birth on land, indicating that a completely aquatic way of life had not yet developed. As we approach the middle of the Eocene epoch, cetaceans begin to fully accustom themselves to a life without land. Basilosaurus, a 16-meter-long predatory whale, populated the global oceans. Its long, slender body, with the first appearance of flippers within Cetacea, make it clear that the Basilosauridae were some of the apex predators of the warm Eocene seas. Smaller relatives of Basilosaurus, the Dorodontinae, had their eyes positioned at the side of the head, further indicating that these cetaceans were not leaving the water unlike their ancestors. The nasal openings now set high on top of the skull, with the presence of pterygoid sinuses allowing these predators to cope with changes in pressure, evident that they were deep diving. The first indication of the presence of flukes is also found within this family, with vertically compressed caudal vertebrae similar to those in modern cetaceans, allowing them to support soft tissue structures at the distal end of the tail. The downfall of the Archaeocetes was their failure to adapt to the changing oceanic conditions at the end of the Eocene epoch. However, the handful that did manage to adapt radiated, leading to the appearance of all extant Cetacea, the Neocetes. Genetic evidence supporting the proposed theory of cetacean evolution is far and in between. However, protein comparisons between modern whales and other mammals support the idea that cetaceans descended from ungulates. It is even revealed that hippos share the same common ancestor, making them the sister group to Cetacea. Cetaceans have overcome countless challenges over the past 50 million years, yet it is uncertain whether natural selection is still in their favour as a new mammalian predator makes its transition from land to sea.